come up with an event for, and maybe see what you consider to be excessive up-down notices on a particular link if that's what you want to try. So sadly, the best technological solution is to really understand the characteristics of what your network traffic looks like, and then focus on trying to look for anomalies. So yeah, we don't have any Linux boxes on the wire, so why are we seeing TTLs of 64 leaving our network? Well, yeah, good luck with that. The other possibility would be link speed changes or excessive up-down notices. You might be able to come up with some sort of a SIM event for that, but in all honesty, I don't really see that that's a realistic way to detect this. The best method is probably user awareness, like everything else. Educate your users on what should be under their desk. Let them know what a network cable looks like. Let them know what a fiber transceiver looks like if you use fiber. And let them understand and be a part of your security. Incorporate it into your annual security refreshers or your monthly refreshers as necessary, and encourage them to ask questions. And the problem is, if you find one of these devices on your network, you should probably be pissed off, but you should really be pissed off about how it got there and not the fact that it is there. Because someone walked into your office, walked past the guards, walked past the secretary, walked past the users, walked into somebody's cube, monkeyed around underneath somebody's desk, and put one of these in, and nobody raised a flag. So what sorts of fun things can we do with this? You can poison web traffic. Obviously, you're in a perfect position to man in the middle. EtherCap has done some initial work on that. I haven't had a lot of time to do any extensive testing on that, but I think that's a potential for a lot of fun to be able to do any sort of client-side attack on any website by proxying through the device itself. You can obviously capture credentials. You can scan the network. Imagine sending a phishing email where the email just appears in the inbox without actually hitting their server, because you just injected it into the IMAP stream. That would be something kind of fun to play with. I haven't had a chance to implement any of that stuff or even look at implementing it, but I thought the email thing would be kind of a fun thing to do. You could pivot through it. If you set up an open VPN call out, you have a full connection, you can route traffic through, you're already set up to NAT, you can do whatever you want with it. And plus, you're blaming the guy behind you. So anytime a network defender would see something weird, they RDP into that box, go, what the hell's going on here? And you got the perfect alibi. You could also have callbacks that are directed inwards. So you set up a listener on the plug computer itself, and have all your local callbacks call back to it and have it call back to the outside world, or you can just interact with it on the plug. Or if you're using one of these, you have a full backtrack distribution available to you, so you can do anything you can do with backtrack on the thing remotely. These are also useful for a trusted insider type of assessment. You could just configure up the plug, ship it out, tell them to plug it in somewhere, and you'll get back to them in a couple weeks after you've finished your assessment. So you can save on travel costs, and it can be a huge savings. Rather than sending a team of 2 or 3 people out all over the world, you can just drop ship a plug to them and surf from the comfort of your home office or wherever you have the plug calling back to. So yeah, what are the common stories I've heard? Fiber. Like I said, people seem to think that fiber is the ultimate solution to all your network problems, that you can't man in the middle with it, you can't do anything with it. And yeah, you can hook up fiber Ethernet, you can run another fiber connector transceiver on this, you can even hook 2 fiber transceivers up with a fiber cable. And it still works. IP still works. Ethernet frames are the same. It's just a transport medium. That's it. Nothing special. So, yeah, I mean, if you have obviously if you have fiber on your network, you know, you run into some logistical problems with having the right cable connectors and using the right kind of fiber and stuff like that. But if your organization is reasonably well funded, that's not really an issue. You just pick up some gig, you pick up some 100 meg, you pick up, you know, a couple dozen cables with all the various ends you could find on it, and you should be good to go. Yeah, it's more stuff under a desk, but it's not a major barrier. Yeah, a lot of people who I've talked with who have fully implemented a NAC solution with agents that do policy routing decisions seem to think that 802.1x is the end-all, be-all network security solution. Amen. And that is really not the case. 802.1x just authorizes the port to go alive and route traffic. Doesn't do any sort of per-packet authorization. It doesn't do any sort of per-packet anything, really. It just says this traffic can go through the switch and go wherever it needs to go. And the agent doesn't really change any of that. All it does is it will check to make sure that the computer behind it has the information it needs to make a decision. So if the patch level's up to snuff, or you log in, or you remember a domain, or whatever the criteria are, it'll still hook you up to the network just the same. And the bridge will pass the traffic just the same. So, yeah, how do we defend against something like this? Well, this is a physical attack. I can't do anything to your 802.1x network if I'm outside the building. It's just the way it is. Yeah, I have to have physical access to a computer that's authorized to implant the device on it. So if I can't get in the front door, guess what? I can't do anything, which is sadly the way it is for most attacks. And it requires an authorized port. So if you're in an environment where you have laptops and you lock up your laptops at night and there's a clean desk with no network equipment, no nothing, well, yeah, not a lot to work with there. So you would notice some weird device plugged into your network waiting for you to plug your computer in the morning. IPsec could be used to mitigate some of the man-in-the-middle issues. Microsoft's NAP solution basically establishes on top of 802.1x IPsec tunnels point to point between all of the clients and servers. So you wouldn't be able to man in the middle easily any of that. Or in all likelihood, you wouldn't be able to man in the middle any of that at all. But you still have to connect to the internet. And unless you route all your traffic through a proxy over an IPsec tunnel, you're still going to have web traffic and stuff like that that goes out in the clear. So there really isn't, I mean, aside from locking your doors and making sure people know what's going on, there really isn't a good defense for this. So 802.1x is a standard that just gives a yes or no question or yes or no answer to, can this device attach to the network? And is it allowed to communicate on the local wire? It doesn't do per packet authorization. It doesn't do any sort of validation that the traffic is legit. All it does is say, yes, this guy can plug into the network. It makes the port go hot. So one of the things that I wanted to make sure people took away with was 802.1x. It does exactly what it's supposed to do. It's when you start getting all the vendor speak on top that starts clouding what its purpose is and what it does. So anyway, anybody have any questions of the dozen or so people that are left? What's up, man? You wanna? Yeah, we got nothing but time. Almost scared everyone off. What's up, man?
Hi. Hello. Just a little comment. In your scripts, I noticed that you didn't turn off STP. So your interceptor machine, your man in the middle, could be leaking STP advertisements.
By default?
By default. If I recall correctly, it is enabled by default when you bring up the bridge.
In older versions of the bridge module, it was enabled. By default, now it is not enabled.
It is not, right?
Yeah.
But it might be useful to put
Okay.
a line in it.
Yeah, that's
so
something that I'll look at doing.
It gets slightly stealthier.
Yeah. Okay.
I was talking to the Pony Express guys in the vendor booth the other day, and they got, I think they're using some of your technology or some of your stuff here to in their boxes. And you mentioned that there's not an easy way to stop this, and while it's not easy, there is a way. It's pretty new. You listed it in there, 802.1ae MaxSec.
Yep.
Will prevent this. It's a nightmare to set up, and
supporting
switches is pretty new.
802.1ae, I believe. I haven't done a lot of research on it, but there's only like 2 Cisco switches out there that support it.
2960S and the 3750Xs will do it.
I can only imagine the nightmare it would be to set up. You'd have to, if I understand it correctly, you would have to upgrade your entire infrastructure to be able to support it.
Well, you need on the switch side, you have to have switch support for it, but then you just need a supplicant that supports 802.1ae. It's actually kind of I don't want to say subset, but it's sort of a subset of 802.1x. Right?
Okay.
They go through 1x negotiation, and then AE kind of kicks in and they negotiate security parameters.
Yeah, it's...
For those of you guys that don't know, it's encryption between the endpoint and the switch port.
Okay.
Right? It's encryption between the endpoint, the supplicant, if you will,
right,
and the switch port itself. So it prevents a lot of these sort of man-in-the-middle attacks that I shouldn't say prevents, makes them a lot harder.
Right.
There's still ways around it, but it's very, very hard. You can't stick an unauthenticated device on the network, and...
Well, and that's probably where things are going to be moving, is on a more per-packet authorized basis.
Right.
But given the fact that, how many successful deployments of 802.1ae are there in the world today, I would bet probably you could count them on one hand, and most of them are on a Cisco campus somewhere.
Agreed. Well, I'm just saying if you want an answer, though,
MaxSec
will stop
Well,
this.
and that's probably the way to move forward with this. And I would be interested to see, I'm sure like anything else, it's a patch to the existing problem. I would be very curious to see an actual implementation and see how well it would take care of an attack like this.
Sure. Cool. Thanks.
Yeah, no problem.
Well, me again, another remark. Perhaps there is a solution to this, but is as extreme as any other ones that...
Could you speak up a little bit?
Yeah, perhaps there is a solution to this, but it's also very extreme. If we dropped 802.1.x at all, and everyone connected to the network over OpenVPN or something like this, and do an entirely different layer to handle this, because... but it's just as you said about IPsec.
Yeah, right. I mean, it's the same sort of thing. You would either have to make sure all of your traffic went over that. Like I said, the NAP solution from Microsoft, that's one of their big points that they tout.
Yeah, but it's the only solution. It's only the really realistic solution that I can think of. Thank you.
I had a quick follow-up to my previous question earlier. I brought up the TTL thing, and basically what I was wondering was, once you move from fully transparent layer 2, you assign an IP to the bridge, you've moved into layer 3 territory, correct?